a class called car, and it's just going to have one variable, maybe two variables, right? It's going to have a current speed and a max speed. Well, that kind of implies a minimum speed, but we're going to say the minimum speed is 0. And when I've given this actually as an assignment to other classes, I added some other information like miles per gallon, and then then you'd have to calculate how far you could go at what speed before you ran out of gas and stuff like that. But in general, this was going to be just a little short one where every time you step on the accelerator, the car speeds up. Every time you step on the brakes, the car slows down, right? And that has to be within the acceptable limits. So it's not a real complicated class. It's only got one piece of data, if I'm remembering this correct. Note 2 if we're doing the max speed. So, car simulator. Awesome car simulator. Okay, so we're going to have two variables in our class, more officially known as members. Instance variables, if we also want to use a techie name for it, like you would in Java or in C++, C#. And those are going to be speed and max speed. Maybe we ought to query the user for the max speed, but we'll just hard code it for now. So we're going to define a class. Class car, and we need an init method. I don't even think it needs to take any parameters, except for the self parameter, which every method needs to have. So when we instantiate it, it's going to set its max speed equal to, our cars only go 100 miles per hour, and the current speed, self.speed, equal to 0. Now let's make a method that returns the speed.
But you need a def in front of the init.
You're right, you're right. Thank you for saving me several English moments. Okay, so that's a method for initializing it. We're going to define a couple more methods. We're going to do an accelerate. We're going to put a brake. And then why not a give speed? Yes, they could just access it by doing, object.speed. But it's not a bad idea to provide, methods for accessing the variables. By convention, if you prefix a variable name with underscore underscore, you're supposed to consider it private, and you're not supposed to access it. The language offers no facilities for actually making private members. A private member is one that cannot be accessed by the client code, only by the class. And Python doesn't support that, so everybody's just got a gentleman's and gentlewomen's agreement that if a variable name starts with 2 underscores, you're not supposed to change that from the client code. But we're not gonna bother with that. That's just more complex typing. Okay, so define accelerate. Now we're going to define how much they are accelerating, or are we just going to say we're going to increase by 5 miles per hour every time? Let's say 5 miles per hour every time. We could pass in the amount of acceleration as a second argument, right? Okay. So let's increase the speed by 5. Self.speed plus equals 5, but if it's greater than the max, we need to lower it to the max. So, you could use an if statement. I'm going to be kind of squirrely and do this. Self.speed is equal to the minimum of either our speed, self.speed, or why did I make it more complicated? Self.max speed. I think I should have just used an if statement. Oh well. That'll probably work. Right?
Self-max speed instead of mad speed.
Yeah, man, we got mad speed. Let's make it max. Alrighty. I hope you see what that's doing. We could have lowered it down to 1 line of code by putting the +5 right there. That's almost too clever by half. All right, and then braking. Same kind of thing, except our minimum is 0. So define break self. Self.break minus equals 5. No spaces between the minus
So
and
wouldn't it be
equal.
self.speed minus equals?
Yep. Why am I spacing out? Apparently I didn't eat dinner. Here we go. And then we need to make sure, you know what, I'm just going to write it the comprehensible way. If self.speed is less than 0, self.speed equals 0. So in that case, we would have used max self.speed comma 0 if we were going to do it like this.
Max self.speed minus 5. 0. Well,
Yeah, right. Okay. All right, and then a get speed.
Finish speed. Turn self.speed.
The get speed, or if we were to use other conventions, it would be get speed with a capital S. I see people do both all the time. I like underscores. I'm going to go back to get speed.
I don't like typing them, so I just do the camel case.
Yeah, the other's camel case. It's by far the most preferred way of doing it if you're a Java programmer. C and C++ arguments get into fights over it. So anyway, self, and then return self.speed. Okay, now we could put this in a while loop and do an input statement, and put a proper framework for testing it. But I'm just going to wimp out, create the car object, accelerate a few times, brake a few times, right? We ought to put it in a loop. Would it take that much time? No. So, down here, choices equal to Q for quit. While choice not equal, why choice equal to Q? Choice is equal to empty string, and then while choice is not equal to Q, we're going to do some stuff. Choice is equal to input. A dot accelerate, B dot brake, Q dot UIT. And then we just have an if statement, right? If it's accelerate. We haven't created our car yet, though. So above the while statement, maybe above the choice statement too, we need to make a new car. Herbie the love bug is equal to car, parentheses, in parentheses. Oh, and apparently I hit Control S, so I may as well save this. Car.py. All right. So what are we going to do now that we have our choice? If choice equals accelerate, Herbie.accel. So if choice is equal to A, then Herbie.accel. And then we could use elif or if, it doesn't matter. It's going to be mutually exclusive. If we use elif, then we can give them an error message if they pick something that doesn't work. But elif choice is equal to B, Herbie.break, not break like an E. We're not going to break our car. And then let's print out the speed. Print car's speed equals, end quote, Herbie dot get underscore speed, or however you spelled yours. All right, this doesn't do any error checking at all. It doesn't tell the user, right? if they didn't type it right or, whatever. That's not the real point of this. The real point was to work on the class and then just get a simple example of using it. I wonder how many mistakes I've made. Accelerate. Car speed is 5. Accelerate 10. I'm going to try to get over that max speed. I wish I'd have made it 10 miles per hour for acceleration, not 5. Alright, we've maxed it out. Can't go more than 100. Now I'm going to start braking. Alright, that seems to work. Now the GUI assignment that I would have wanted you to make would have been a little GUI with a speedometer. It would just be a number, right? No fancy graphics. Fancy graphics would be cool. And a brake and an accelerate button, right? You'd have 2 buttons, one for braking, one for accelerating, maybe a third for quitting. Although you could always just close the close box to quit. So if you're feeling like doing that, let's make that an extra credit assignment. All right. Hope that makes sense. Alrighty, I'd like to go back to HTML and JavaScript, but I want to make sure everybody's got this working. Okay, what would be cooler than just hardwiring 100 in it, right? Because if you're in a Lamborghini, that's obviously not your high speed. So we're going to pass in to our constructor because I want to be able to do this. Herbie can go 200 miles per hour. That's one fast VW. So here, half of y'all probably never saw Herbie. All right, so then we need a name of a parameter here. Max would be a terrible name because it's already the name of a function. Max underscore S. Max underscore S. And then we do max underscore S right there. So we tack that on to our parameter list. And then on the next line below it, max underscore speed is equal to max underscore S. Just make sure it's the same exact variable name as that. And you see this plus and minus 5? That's another hardwired, hard-coded value. Right, if you're stomping on the gas on your Lamborghini, it's going to increase by a lot more than 5. We can make that a variable too, but no reason to go absolutely nuts. All right, that ought to work. We're going to go on to do JavaScript. We still have considerable time today. We've already talked about HTML. We're still going to be working within the framework of HTML, but not just HTML. So if you remember what I said, JavaScript is a way of modifying the contents of the web page. The HTML is loaded, the browser builds an internal model called the document object model of the web page, and then part of it goes and actually renders it based on that. And then the scripting language allows you to make changes to the data that's loaded in memory. What's this file I have called tags here? All right, a whole bunch of tags. What do you know? But we talked about these, right? HTML begins the document, head marks off a header section, body marks off the body section, title, puts a title up here. Header 1, header 2, strong makes the text, bold. Big makes it bigger. We didn't actually use that. Div blocks off a chunk of the document. Image puts an image into it. P is a paragraph of text, so that can just be one line, right? Span is used within a paragraph to change it. You use div to define blocks, but span just changes a part of a paragraph or the whole paragraph. Href goes to a link when we didn't talk about tables. Maybe we'll throw in a table today. And you know, this could have a far better name than just notes, eh? HTML and JavaScript notes. All right, if you refresh your contents page, you'll see a much better folder name. Alrighty, what is JavaScript? It's a programming language designed for web pages. That's kind of vague. It's designed to make interactive web pages. It enhances web pages with dynamic and interactive features. It runs in the client, meaning that all that the JavaScript is doing is it's modifying the way that your browser behaves. You can make the JavaScript communicate with the server, but it's not a server-side product, you know, it's the client-side product. So common JavaScript tasks can replace server-side scripting. Why is that important? Because what if your program had to hit the server every single time you did something? Like what if you clicked on a menu and it was going to do a pull-down menu, right? You click on your account name and then it pops up a list of choices, right? Like preferences and, you know, log out and stuff like that. It'd be really annoying if as soon as you clicked on that menu, on the menu bar, it had to hit the server to bring it back in, right? You know, and then you're waiting 5 seconds for the page to come back so that you could actually click on, you know, preferences or log out. So, as much as you can do on the client, the better off you are. You really only want to be communicating with the server when you actually need to, right? Like when you actually need to submit something so that the server can record it as a purchase or something like that. So JavaScript enables shopping carts, form validation, right? You're typing in a password, but there are rules for the password. You know, enter new password. It has to have an uppercase letter and it's got to have a number and a special symbol and be more than 8 characters long, right? All that stuff. You don't want asking the server if your password is good because then you're sitting there waiting 5 seconds. The JavaScript part.
Also, then it's saving whatever password you enter to the server on RAM.
Right, right. Then, yeah, and so then you're transmitting that putative password. You know, it can be intercepted unless you encrypt it. Anyways, so instead you want the JavaScript to check it. You know, right there, right then and there. You know, nope, you didn't put any special characters in it. Special graphic and text effects, image swapping. You know, you move your mouse over, and the sad face turns into a happy face. Image mapping, clocks, and more. So unlike HTML, JavaScript is case sensitive, just like our variables in Python, right? Python is case sensitive. All programming languages are case sensitive, pretty much. Back in the 60s, there was a programming language where all the commands were uppercase, all the variables were lowercase, and that's how it distinguished between the two. So if you wanted to make a variable called max and a function called max, you'd put one in uppercase and one in lowercase. Anyways, so the dot syntax, we've kind of seen that already. Document.write. Well, the document is a document object model, so if you do document.write, it's going to insert the words hello world onto your page. Certain characters and terms are reserved. Hopefully they'll tell us. And JavaScript is simple text. It's just pure text like you'd create with a text editor and save. Which is good because the JavaScript is downloaded to your machine just like the web page is. And we've already seen that the web page is simple text, right? But you ask the server for it, it coughs up the simple text. It also sends down the pike the JavaScript, which may be part of the same file or it may be part of a secondary file. So, JavaScript programming uses specialized terminology. Well, what programming doesn't? Understanding JavaScript terms, fundamental to understanding the script. So we have objects, properties, methods, events. Now we've hit some of these terms, right? We know what a function is. We know what a method is now. A method is, a function that's attached to a class. A property is a variable that's attached to a class. Different languages and different disciplines call it different things. Fields is a common term for it. Instance variables is another one. But a property is a variable that's attached to a class. So in our class, we had a speed and a max speed property. And events are things that are generated by the user. You know, the user clicks this button. The user closes the window, stuff like that. We know what an expression is. We know what an operator is. We know what variables are because we are awesome. So what is an object? Well, it's an instance of an object, of a class. Obviously, there's all sorts of different kinds of classes in this language. Windows, documents, images, tables, forms. Everything you can see on the screen is part of a class. Objects should be named. Otherwise, how can you modify them? How can you access them? Objects have properties that act as modifiers. Well, I've forgotten why I put that in there, or stole this text from wherever I did, one or the other. So properties are object attributes, right? Document BG color. You want your script to change the color of the page? Document.bg color is the property you would change. So that's the property, and that's the object, right? Well, it's highlighting both. We're not highlighting. But document is the object. BG color is the property. So object properties are defined, I would say accessed, by using the object's name, a period, and the property name. You're not defining it when you use that, right? We didn't define document.bg color. We accessed it. We either set it or we retrieved it, one or the other. So what are methods? They're actions. We would call them functions. This is like a JavaScript for non-programmers, right? We know what functions are. Applied to particular objects. The methods list what an object can do. In general, a class is a way of defining a collection of data and then the things that can happen to that data, right? Our car was a collection of data, a speed and a max speed, and then the things that could happen to that data, right? It could break and it could accelerate, and one of the values could be retrieved. So some people call them behaviors. So methods are actions, functions. Other disciplines would call them behaviors applied to particular objects. So the methods are what the objects can do. If you were going to write a printer object, right, you'd want a method that would check the queue. You'd want another method that might, check to see whether the printer was online or not. You'd want a method for submitting a new print job. You'd want a method for canceling that print job, that kind of stuff. So again, document is our object, and then write is the method. This one is a lot shorter than the other document. That's okay. So events associate an object with an action. There are lots of events that the browser will generate as you move your cursor around on the screen. Every time your cursor moves over something like an image or whatever, it generates an on mouse over event. Now, if there's no handler set, then that's just going to be ignored, right? I'm sitting here, I'm looking at this web page. Most of this stuff is, may not have a mouse over handler, but some of these things do, right? I move over the button, it changes color. Kind of subtle, but it does. So there's an on mouse over event handler for each one of these objects. And see, they draw cute little things, that makes the web page interactive and easier to use. If you can move your mouse around and you see changes in it, depending on what you're pointing at, you know that it's a clickable object. That's our convention. Why would it change if you move over it and it's not a clickable object? So, another one, on submit. If you have a submit button, like you're submitting a purchase order, then you might handle the submission. Maybe there's some additional data you need to collect before you actually process that submit by invoking the server. And so the user triggers the events by moving their mouse around, by clicking on things, by typing on things. Just like in our own GK interface, we had buttons that generated events. And when the button click occurred, it called our function. Well, that is in effect an event handler. So what are functions? Good thing we already know this. It's a name statement that performs tasks. You know, our way of defining it in the past has been a block of code that has a name, but I guess this is getting a little bit more generic. It performs a task. Function, do whatever. Statement here. That's pretty generic. That's all right. The curly braces contain the statements of the function. That's something different. If you guys have done other programming languages, you're used to that syntax, right? Something like this. And you put some code in here. And then if you had another block, right, then you could use more curly braces like that. Now the thing about curly braces is that, unlike our language, indentation doesn't matter. Yeah, that would be just as valid. It would be ugly, nasty, hard to
pretty ugly, yeah.
But that is just as valid because the code blocks are marked off with the braces rather than by indentation. Very few languages go by indentation. Python does.
But you don't have to type curly braces.
Right. I'd rather type the curly braces. Okay, so JavaScript has built-in functions. You know, it's probably got square root and, you know, things like that. And you can write your own. Just like Python has built-in functions. So what are values? Values are bits of information. They can be numbers. They can be characters enclosed in quotes. They can be trues or falses. They can also be objects. Like we had a turtle object and we had a car object, stuff like that. And a function can be a value, it says. I would disagree with that. A function returns a value. It's not a value in and of itself. I would argue with them about that. I probably wouldn't argue too much about it because I can see why they would say that. Because you could store the address of a function in a variable and then invoke it by that value. But that's pretty weird. We know what a variable is. It contains a value. You use the equal sign to specify that value. If you want to use MIT language, you say that that value is bound to the variable. All right. Anyways, the variable contains that value. Whether it's a reference to an object, right? Or whether it's a primitive value like a number or whatever. So variables are created by declaring. You use the var command to create a variable. We haven't had to create our variables in our language. Right? So we were able to get away with stuff like this. You know, x is equal to 3. Y is equal to x, you know, times 2. But no, we've got to do this. Var x is equal to 3. Var y is equal to x times 2. That still is a bit different than your strictly typed, your strongly typed languages like C++ and Java. Right? Because in those languages, you actually have to give a data type. You don't just say, oh, by the way, this is a variable. You have to say, this is an int, or this is a string, or this is a float, something like that. But, you know, the var keyword declares a variable in JavaScript. We didn't need anything of that sort in Python. So JavaScript is also considered a scripting language. It's loosely typed. It's not really compiled, right? It's just executed in a script interpreter. But it's got some rules that it has to follow that differ from Python's rules. They're loosier than strictly typed languages like Java and stuff like that. Here's what I mean by strictly typed. If I was going to write a function in Java called sq for square, and it took x, and then we did r is equal to x times x, and then we did return r, that's great. But in Java or C++, another strictly typed language, you might have to do it like this. Float sq, parentheses, float x, float r is equal to x times x, return arc, like that. You see, you have to define what he is returning, what kind of data he is returning. And if you return something else, like a word, it won't even compile. The compiler checks for that. We could do that here. It wouldn't make any sense, right? But, you know, we could return anything we wanted to out of this kind of function. But in a strictly typed language, you have to return the data type for which it is declared. Similarly, if you're going to pass in an argument to fill this parameter, it has to be of the correct type or something that converts to that type, right? We couldn't pass a string to this. We could pass a string here, and then it would blow up when we tried to do this operation, right? So Python, you know, you get more runtime errors because it's not strictly typed.
You get less compile errors because it doesn't really compile.
Right.
It runs.
It's nice if the compiler catches your syntax errors, right? But it's not always going to do that because this would be fine syntax, just depending upon what you called it. Like if you called square hello, that's going to blow up because you can't multiply hello by hello. All right, enough diversion. JavaScript is a little bit loosier-goosier. Like I said, your function doesn't have a defined return type, unlike a strongly typed language, so it's much more like Python in that respect. Expressions. We know what expressions are. You put your variable on the left-hand side, you put your expression on the right-hand side, or if you know it's part of an equal sign, you know, or a comparison or something. So varmonth, it says that this is an expression. This is really the expression.
Well, the whole thing's an expression.
I would argue with that, but it's saying that the whole thing is an expression. So I would call this a statement, and that this is the expression. Why do I say that? Because, you know, if you have 2 plus 2 here, that is the expression. That is the statement, in my opinion. But apparently I copied some of this stuff rather than writing it all myself. Shame on me. So expressions end in a semicolon. See, everywhere they're using the word expression, I would use statement or declaration. All right. Operators. They're standing by. Used to handle variables. You can use addition. You can compare. Something tells me it's going to be double equals. Logical operators such as and. Again, they're spelled out, not with the cute symbols that Java and C++ use. You can have control operators such as if. Assignment operators, the equal sign. String operators. So, JavaScripts can reside in a separate page, or they can be bundled up on your HTML page, which is how we're going to do it. They can be embedded in the HTML. You're going to stick them in the head, or in the body, or in both. For the most part, we're going to be putting our JavaScript functions up in the head. But you can also bury them directly down, like if you create a button, you can add an on-click handler to that button, and then have it execute some JavaScript right there rather than call a function in the head. And you'll see what I mean in just a moment. So JavaScript object attributes can be placed in the HTML element tags. For example, when the body loads, I want to pop up a message that says welcome, because that's what we all love, is pop-up messages when we're browsing. Maybe we ought to play with that. Let's actually get some stuff going on here. Load a text pad. HTML. Oh, if I save it as HTML, then I'll actually be able to read it. It'll be a nice large font. Alrighty, so this is May1.html. Make sure this type, save type, is HTML, so it doesn't call it .html.txt. Alrighty, so at some point we're going to put some stuff in the header. So I'm going to add a header tag, a head tag. I'm going to close that, because by and large everything that has an opening tag has to have a closed one. Very few exceptions to that. And then we're going to have a body. And right now, this is just, the paragraph is going to say this is a page. Right? So, angle brace P, this is a page, and then close our P tag. I should indent this over if I'm doing strict indentation, slash body, slash HTML. All right, I'm going to Control S to save it. I'm going to hit the planet in order to view it, and it says this is a page. That's what we wanted to see. But now we're going to add some scripting. Body, and then we're going to add tag that says, do you remember the tags we've been using so far? Excuse me, the attributes we've been using so far. Style is equal to blah, blah, blah. Instead, it's going to be onload is equal to. And we're going to put a little bit of JavaScript there right inside of the tag as an attribute to the tag, the contents of the attribute. So, inside the parentheses, we're going to type in a JavaScript command. We're going to take advantage of alert. Now notice that, well, be careful when you use your single quotes and your double quotes. Just like Python, you can use either one, but you have to put some care, and I'll show you what I mean. So, when the page loads, it's going to generate an onload event. And when that happens, it's going to call this event handler, which is alert. Now, since I opened this with a double quote, I need to do a single quote here. Why? Because if I did a double quote here, it would think that was the end of the string. So alert, and then let's print a message. Hi there. End apostrophe, end single quote, end parentheses. In my opinion, there ought to be a semicolon there, although they didn't show it. I'm going to put it there. And then end double quote. I'm going to space this out to make it a little bit easier to see. Like that. There, we've written our first JavaScript program. It's just one statement. Let's run it. And it did pop up our dialog. This page says hello there, or hi there. We could define a function up in the header, and we could call that function from our onload event. That's typically what you do, right? You don't embed a whole JavaScript program right inside, the value of an attribute. Well, you could. Poor form.
So you're doing like SQL injection.
Did everybody get this working? I don't want to blaze on because we're going to be adding some JavaScript to it. But some interesting stuff happening. Save it. If you hit file save.
Yeah, you have to save it before you open it in the browser.
Save, and then launch it with Flash. Yep. Anybody else? Planet, launch it. Yep. All right. So the JavaScript can reside in a separate page or up in the header, or as we've seen, it can even be any attribute of a tag in the body. Using separate JavaScript files. Linking can be advantageous if many pages use the same script, right? You might have a website that is composed of 100 web pages, and they're all supposed to be sharing the same functions. Well, you would not want to copy and paste your JavaScript into the header of every single HTML file. Instead, you'd put them in a separate file and you would link to them. So, in that case, in the header, you would do this. Script source is equal to myjavascript.js. And then you could tag on some additional things. What language is it? It's that. What type is it? It's text. Honestly, it would work if you just did that. We're not going to do that because I don't feel like opening up a separate file to put our script yet. Okay, so embedding JavaScript in HTML. Script language is equal to JavaScript that looks very similar to what we did here, right? Or what we did before I deleted it. But we had source equals. We had an extra attribute here for our script tag, specifying the file. And if you don't specify a file there, you can put some code right here. Now here's something weird. You're going to see this a lot. Once upon a time, a lot of browsers didn't support JavaScript. And so you would use hiding, which is using an HTML comment to hide your JavaScript. Why? Because this is not HTML. And a non-JavaScript compliant browser wouldn't know what that meant. It might flag it as an error, you know. Nowadays, are there any browsers that don't support JavaScript? I don't know. But let's go ahead and put a comment in our code just to remind ourselves that that's what that actually is. So a comment in this language, less than, exclamation, hyphen, hyphen, and then it ends in hyphen, hyphen, greater than. Okay. So I'm going to add a comment up at the top. Less than, exclamation, hyphen, hyphen. This is a pretty cool comment. And then dash, dash, greater than. And of course, we could have put that all in one line. A lot of examples you see will hide JavaScript within these things. And that's weird, in a way, if you think about it. But the JavaScript interpreter ignores that, right? Because you'd think that that was commenting out your JavaScript too. But it doesn't. It only comments it out as far as HTML is concerned. The JavaScript interpreter ignores those comments. And so any JavaScript code between here and there, as long as you have it enabled in your client, would be processed. So HTML command tags, comment tags should bracket any script. Double slashes are the comments for JavaScript, right? So we've been using hashtags. We've been using the £. But that's the JavaScript comment. And you'll see that in a great many other languages. JavaScript is roughly based on the C syntax. So a lot of things that you see in C and C++ do show up in JavaScript, including the //
A little bit similar to Java, even though it's completely separate from Java.
Yep. All right, I want to get to this point where we're actually typing some awesome code. Using JavaScript in HTML tags, event handlers like on mouse over. Now to get this little bit of code to work, you would need 2 images on your page. I say we do that. Go and load up 2 pictures. Puppies. I want more puppies. All right, so I'm going to type in puppy into my Google search. I'm going to click on one, right click, save image as, and so this is going to be puppy 1. And then go and find a .jpeg. Take note of your file names. If one of them ends in PNG or something like that, you're going to have to take that into account in your code. All right, now I'm going to find another puppy. Save image as puppy2.jpg. And you know what? I don't think we're ready to do this because we don't have an image on the screen yet for this to replace. But we are going to need those guys in just a minute. Oh, yeah, we do. Yeah, there we do. Right? Check it out. Okay, so we're going to add an image tag. And then we're going to add an on mouse over comment. Notice that on this tag, we have an attribute that we haven't used before called name. That attribute is how the JavaScript finds what it's going to change, right? because when our mouse moves over this thing, it needs to change document.logo.source to our new path for the image. But that's the only way you can find it. I mean, this is an image tag, but if it didn't have a name, he wouldn't be able to talk to it. It's like a faceless person, an anonymous person. You can't go, you know, hey Denise, if you don't know the person, that the person's name is Denise. So, we need a picture in our code. Well, let's do that. Above or below your paragraph tag. Or in it. Anyways, image name is equal to, let's just use exactly what they did, logo. Name is equal to quote logo, end quote. Source is equal to, and then one of your file names. In mine there were puppy1.jpg and puppy2. Puppy1.jpg. Now I better test it before I go any further, because if I'm not seeing a puppy, I've done something wrong. Alright, so it says hi there. I'm going to get real annoyed with watching, you know, it pop that up every time I run it. But there we go. I have a puppy. I'm pretty happy about that. Now we're going to add some JavaScript. Let's add an event handler to our image tag. I'm going to just go over here and in front of this open brace, this closed brace, I'm going to hit a new line. And the syntax that we're going to follow is on mouse over with a capital M. And we're going to have to be real careful with our single and our double quotes again. The convention that this help page, that this PowerPoint follows, is that the attribute value is enclosed in double quotes, and then if there are any quotes to be put in there, they'll be single. So on mouse over, capital M, everything else is lowercase, equals, go ahead and do a pair of quotes, right? Because you know that you're going to be putting stuff in there. And then you're going to modify some stuff between the quotes. And we're going to hit our document following the document object model. And we're going to say document.logo.src. Document.logo.src equals, now I have to use single quotes here to differentiate them from the double quotes which contain the entire attribute value. So source equals puppy2.jpg. And then another quote, because for every open quote you have to have a closed quote. And again, although it doesn't show it, I'm going to put a semicolon there. Alright, so again, it's kind of hard to see. I'm going to put some spaces in places to make it easier to see, right? Double quote, document.logo.src equals single quote, puppy2.jpg, end single quote, semicolon, end double quote. Now that ought to work. When we move our mouse over our puppy, he ought to change. So save your document. And it doesn't do it. What do you know?
On the PowerPoint, the mouse over events are in the ahref tag.
It worked, both href.
Work for you? Well, what I do wrong?
It's not working.
Well, don't show me the code again. And you're correct. It showed it in the.
Put the image before the paragraph.
Okay. First paranoia. Maybe the semicolon. Go away. I don't think that's it. Second paranoia. I'm going to remove all the extraneous spaces from my tags.
Did you save it before you did it?
Yeah. Well, I can't say that I did it that time. Yes, I did. Alrighty.
Oh, it's so big that when you're going over the thing, it's switching it, I think, automatically.
Oh, it's already switched by the time. Okay, let's make the the puppy tiny, right? So we're going to give them a style with a width. So I'm going to tack on another attribute. Good catch, good catch. And then I'll still curious why it's not working for you. I'll do some walking around in a minute. Style is equal to, and we're going to put some CSS commands, just one in particular. Width, width, equals 200 pixels, 200 px, in semicolon, end quote.
With CSS, isn't it a colon instead of an equal?
You're right, it is. In CSS, they're separated by colons. So width, colon, 200 px. You know, part of me knew that that was wrong even as I typed it. Okay, so there's my doggy, and he changes as I move the mouse over. All right, I'm going to wander around and make sure that everybody's good with this. But we've written some JavaScript now. You know what confuses me about their example is, wouldn't it mean that whenever you moused over any part of the document, it would change to the next logo? That doesn't seem cool to me. All right, so we've already seen onload, so I'm not going to tack that one on, right? In fact, it's already kind of annoying us that every time we load our document, it says alert. So you know what I'm going to do, in our precious few minutes that we have left? I'm going to comment this one out and then add another body tag. Right, so comment it out. In front of body, put angle brace, less than, exclamation point, minus, minus. And then at the end of all that, do 2 more minuses and a greater than. And then just put another body tag, like that, right? That way we can bring that other code back whenever we wanted to. All right, much better. So JavaScript functions go in the script section in the header of the document, whereas HTML tags go in the body. Of course, you can have a couple of tags up in the header too, but they won't affect what you see. So for example, along with our title, which we never set, we're going to create 2 tags up here, an open script tag and a closed script tag. So let's do that. Come up here into the header, and between the 2 header tags, less than, script, greater than, and then on the next line, less than, slash, script, greater than. So we have a script tag, and then we have a closed script tag. Now we haven't put any functions there yet, but we're gonna. Now if we were going to follow the strict specifications, we would then hide our scripts, in some comments like that. I may skip that if the slide doesn't tell us to do that. Alrighty, so we're going to write a function called change demo. Maybe I'm just going to call it, let's call it the whole thing. So up in my script, can I get both of this stuff on the screen at the same time? That'd be nice. Alrighty. So up here in script, function, instead of def, change, and in capital D, demo, parentheses, in parentheses, open curly brace. And now we're going to use something called get element by ID. You can also get elements by name, which is how that other one worked, right? We had something and we changed its name. But here, we accessed it by its name, I'm sorry. E standing for element. And now we have a lot of typing to type, I'm sorry. Document, all lowercase, document dot, and then get element by ID, where every word except the word first is uppercase. So we're using good old camel case. Get, all lowercase, element with a capital E, by with a capital B, ID, lowercase d on ID, I almost typed it uppercase, parentheses, quote, I'm using single quotes because that's what their thing demonstrates, So parentheses, single quote, demo, end, parentheses, end quote. And see, here we go, just blazing along without our semicolons, whatever. And then E dot enter, all lowercase, HTML, all uppercase, is equal to, quote, hello JavaScript, end quote. So that's our script. But we need some text down here that actually does that. So we're going to have to put a little bit more. Alrighty, so down here in the body of my code, I think I'm going to put it just above my P. This is a page business. I'm going to start removing some comments so that I can get all the stuff on the screen at the same time, or at least as much as I possibly can. Okay, so under my body tag, button, this is a tag, so it's in a brace, less than, button, and then on the next line, type equals quote button. Seems obvious. On click, this is another event like on mouse over and on load, equals quote. And remember, all their attributes have been in double quotes, so double quote, change demo, end quote. And then we're going to need some text. There's a typo here. They have a M ending brace there.
Because it's a property of the tag.
But then they have a close button tag underneath it, so there shouldn't. Yeah, you're right. Okay. Okay, so button on type equals button, on click equals change demo, end quote, and then some text. Click me. And then end brace, or excuse me, greater than sign. And I know it's a lot of typing and it's slightly hard to read. I apologize for that. This will be the last thing we do to it. But we need something with the ID of demo, right? Because otherwise there's nothing to change. So how about down here where we see P? Do P, where it says this is a page, ID equals quote demo, end quote. So I just changed this line right here, as well as adding my button. And I hope this all works. I hope this all ties together so we can walk out of here feeling awesome. Let me run it and see if I'm lucky enough. Well, look at my little teeny tiny button.
Yeah, the click me goes outside of the button tag.
That's what I figured. I
It
thought
don't mind. That's weird.
worked for you.
No, it didn't work, but I got my button. It's clickable.
Okay, I made a mistake here because how do you call functions?
Oh, parentheses.
Yeah, got to have the parentheses there. Still not doing that.
No.
Okay, so I'm going to put an alert statement in my script so that I know it was called. Alert change demo, right? I just added this line here just to see if it's working. And for Pete's sake.
You have the west end, you moved it.
I have an opening brace, but I don't have a closed brace. That's a pretty bad thing. Maybe.
Oh, right.
Oh, yeah.
All right. And what were you suggesting?
That'll do it.
Is it not working? Oh, it's working.
That will do it.
All right. Change demo, and then it changes our paragraph. Excellent. Okay. So, I'm sorry that I made several mistakes. But let me create a Dropbox. You can load your HTML file there. I want to see if the HTML assignment that I had queued up is worth making y'all do. Simple JavaScript. See what it is. All right, make a simple web page that has a header and several paragraphs of text and an image. Add a button that when clicked replaces the image with another image. Kind of similar to what we did, pretty much. Add a second button that changes one of the paragraphs to say JavaScript is cool. Make the web page as pretty as you want and put your scripts in a script tag in the header. All right, I think that's worth assigning, y'all, in my opinion. Whatever. Give ourselves several weeks to do it. All right, next week we're going to brush upon JavaScript a little bit more, and then we're going to use Python as our web server to do some server-side programming.
Should we upload to other things?
Yeah. Make a Dropbox for that. LM. Okay. Alright guys, there's a Dropbox there. Let me make sure I put it in the right folder so you can spot it. La-di-da-di-da, probably not. Alright. Okay, refresh your Dropbox. You'll see M. Just give me your HTML. Go ahead and give the class document too, right? Because we wrote a class, so upload the PY file as well. Alright, just a sec. Let me stop this.